Hello, basement programmers, and welcome. Are you curious about Oracle Cloud? Do you know what OCI can help you do to meet your goals of cost, security, and performance? Maybe you're starting to think about expanding into the cloud from your data center. Maybe you're thinking about adding a new cloud provider to your existing one. Or maybe you're just looking for a quick overview. In any case, like, subscribe, and watch my next video, OCI for the AWS Developer. Hi everybody, and welcome to this video, OCI for the AWS Developer. Now, I do have to say here, I am employed by Oracle. I'm no longer employed by AWS. The material presented here is my own findings as I'm working through the landscape that is OCI. The opinions expressed are my own and not necessarily Oracle's. That said, I am going to try to keep my opinions out of it because my goal with this video, as with all my videos, is to help you understand the technology and make up your own mind. Hopefully you'll find this video helpful. So we'll start with a quick intro into what Oracle Cloud is. If you think Oracle Cloud is only for databases, you can be very pleasantly surprised here. There's a wealth of functionality waiting for you in the console. From there, I'm going to dive into accounts and organizations. This gets to the heart of how you're actually going to consume the Oracle Cloud services. We'll talk a little bit about user management, because obviously you have to be able to connect users into your account in order to do anything useful. And there are some unique aspects about OCI that you need to understand. From there, I'm going to cover some of the OCI basics like networking, compute, storage, and yes, a little bit about databases, because it is Oracle after all. All right, so let's talk about OCI, or Oracle Cloud Infrastructure. Now, you'd be forgiven for thinking that OCI is a one-trick pony. For decades, Oracle was synonymous with databases, and really big databases at that. 10 years ago, nobody would have considered the Oracle name as having to do with anything but large corporations. You think Oracle, you probably think big, expensive, old guard technologies. Well, Oracle Cloud is a very different animal and needs to be approached from a completely different mindset. When it comes to the cloud, OCI is all about focusing on what you need to be successful and trying to make that success as secure, robust, and inexpensive as possible. When you think about it, that's what cloud is all about, helping to make you successful. Because if we don't, you just walk away. Now, if you've never looked at OCI, I'm here to tell you the platform exists at all levels you would expect from a cloud provider. There's infrastructure. You can create virtual networks, virtual servers, storage. You can deploy your applications just like a data center, as you would expect. I mean, what's cloud without being able to spin up a virtual machine, right? There is a robust infrastructure layer that provides you all the foundation to build all the apps that you need on the infrastructure you want, with a flexibility so that you don't end up over-provisioning or compromising performance. There's platform services, things like Autonomous Database, to help you focus on the apps and leave the management to Oracle. When was the last time you heard a DBA getting excited about replacing disks or troubleshooting networks, right? With Autonomous Databases, those things are a thing of the past. But Autonomous Databases goes beyond that and actually helps you automate database tuning as well. Want to run containers? There's a managed Kubernetes service to help you host your containers on. Need virtual desktops? Got you covered there as well. Platform services are where the cloud really differentiates by providing you the ability to offload work to Oracle. And who wouldn't like to have a little bit less work to do, right? And of course, SaaS offerings. AI services that you can just use, like vision, speech, language, and documents, generative AI, object storage. It's all there ready for you to use. So if you thought OCI was just about databases, it's time to look again. Now, the first thing to understand with any cloud provider is the way that cloud is built. There's often a lot of differences, and if you approach it thinking it's all the same, you're going to run into some surprises here. This is critical for you to understand so that you know how to get the best way to consume resources and how to lay out your applications. At the top level, OCI has a concept called realms. Think of this like a collection of regions. There are three realms here. You've got commercial, where pretty much everybody deploys their stuff. You've got government, special regions for government customers in a few different countries. You've got an EU sovereign cloud, which are regions dedicated to EU customers that are separate from the commercial realm. And of course, you've got dedicated infrastructure that can be deployed at a customer's site specifically for them. Every realm is separate from each other's. Now, AWS doesn't have a specific term for this, but there is a similar concept with the commercial regions, GovCloud, and China regions that are separate. And the next level down from realms, you have regions. These are fundamentally the same between AWS and OCI. It's a geographic area where cloud services are provided to you, the customer. At the time that I'm writing this, OCI has 40 regions and AWS has 32 regions. Basically, you want to choose regions that are close to where you're going to be consuming resources and where your customers are going to be to have the best experience possible. There are a couple of differences here, though. First, with OCI, you have to subscribe to the regions you want to use. You have one region that automatically gets activated when you spin up an account. The rest you have to greenlight as you decide to move into them. This helps to prevent sprawl and avoid having some random instance that you spun up somewhere in the world and literally have no idea on earth where it is. With AWS, some regions are opt-in, but there are a lot that are automatic. Now, of course, you can create some security policies to restrict users from spinning up those resources in regions that you don't want to use, but those are at a policy level. So you have to do something to make it happen, and you have to make sure that the policy gets applied. Second, with OCI, you have region pairs that are designed to help you replicate data from one region to another easily. Now, AWS doesn't really have this idea of a paired region setup. You can build functionality to replicate data from one region to another. It's just slightly different in how it's set up. Now, regions get sliced up into individual pieces. In Oracle, they're called availability domains. In AWS, they're called availability zones. Now, OCI has a minimum of one availability domain per region, with some regions having 3, and AWS has a minimum of 2 availability zones per region, with most regions having more, up to Virginia that currently has 6. Now, the availability construct on both sides is designed to help make your applications more resilient to failures. The final thing I want to mention here is fault domains. This is a unique feature of OCI. Every availability domain has at least 3 fault domains. This spreads your spun up infrastructure across multiple parts of the data center. Think of it like making sure that your virtual machines get spun up on different hosts, different racks, different network segments. The idea here is that by spreading across multiple fault domains, your application can be fault tolerant to things like planned maintenance events, hardware failures, etc. It's very unlikely that a hardware failure will affect multiple virtual machines running across different fault domains. Now, AWS doesn't really have this idea. When you deploy into an availability zone, AWS figures out where it wants to put the instance. Okay, let's talk about accounts. Now, unfortunately, the word account has many different meanings and it gets confused a lot in conversations, especially when it starts coming to cloud services. In this case, I mean account as the construct that allows you to consume resources. In AWS, this is called an account. In Oracle, it's actually called a tenancy, which helps break up that confusion a little bit. In both cases, you're going to sign up with an email address and password. Though in OCI, you're also going to define a tenancy name as part of that setup. In AWS, you get an account number. Once you're set up, you get access to the free tier of services. Now, the free tier is very different here between the two providers. OCI's free tier starts you off with $300 worth of credit for 30 days, and then transitions into what's called the always free. This means that you can't accidentally end up with a bill and you get access to a set of services that are ongoing. As the name suggests, always free includes access to a certain amount of free usage. For example, you get 20 gig of object storage potentially up to 4 ARM instances for VMs, and a lot more. Now, AWS, on the other hand, has a free tier that lasts a full year. However, there's a gotcha there, and it's a big one. There's nothing protecting you from exceeding the free tier and getting a bill even during that free period. If you use too much of a service, you'll get a bill. Some services don't have a free tier at all, so if you use them, you'll get a bill. Some services has a free tier which is much more limited, say 30 days. It's your responsibility to monitor what you're using and make sure your usage falls within that free tier stipulations. Now, some services have a free tier that continues after the 1 year as well. For example, Lambda, you get 1 million free requests and 3.2 million free seconds of computing time per month, and that lasts forever. Now, both providers do have budgeting alarms that you can set up and configure alerts for, but you have to do that yourself, and you have to remember to take action when you get that notification. Neither provider is going to run in and arbitrarily kill your stuff off, which is probably a good thing. At some point, especially if you're a large, complex organization, or you're like me and you just want to separate things out, you're probably going to get to the point where you need multiple accounts. Now, OCI handles this with the idea of child tenancies. You can set up child tenancies as long as the new tenancy is in the same realm as the parent. With AWS, this is handled through the organization service that you actually have to go in and set up as a separate process. Both options are going to allow you to have things like strong isolation between workloads and individual service limits for your accounts. When I was talking to customers about the idea of multiple accounts, I basically described it as having a brick wall between your multiple workloads. There's no chance that anything is going to accidentally cross an account boundary. All right, compartments. This is a unique OCI feature. At first, I really didn't understand compartments. But then as I started learning more about OCI and how it's set up, it hit me that this is actually a really useful construct. Compartments are logical segments inside of your tenancy. Think of it like sub-accounts. You can create a compartment for specific resources, specific projects, specific teams, whatever makes sense for your organization. You can then allocate resources inside those compartments. These are logical segments, so there's nothing preventing you from accessing resources across compartment boundaries as long as you have the permissions. However, and this is where the cool part comes in, you can set up policies at the compartment level. So you can have a policy that says my development manager has full admin control over my development compartment without giving access to anything in the production compartment. There's no complex tagging required or anything like that. If something's spun up in that compartment, they have admin access to it. You can then nest compartments. So, for example, each developer could have their own compartment inside the development compartment, and then permissions will cascade so that your development manager automatically gets admin access to all those subcompartments. As a tenancy administrator, you can set up individual quotas and limits at the compartment level, and you can even set up compartment level budgets and alarms as well. This gives you a huge amount of flexibility on how you lay out your account. Now, unfortunately, with AWS, there's really no parallel concept to compartments. You'd probably end up creating additional accounts to facilitate this level of functionality. IAM, or Identity and Access Management. It's your fine-grained user access control here. Now, both providers have a service called IAM, or Identity and Access Management. With OCI, you create users inside of a directory inside of your account. With AWS, you create users directly inside of IAM, unless you're federating. What that means is that in AWS, every account has one set of users. In OCI, you can have multiple directories with multiple sets of users. You can even scope a directory to a particular compartment. So, for example, you might want to have one directory for employees and a separate directory for external users. Now, AWS does have Cognito that you can use as kind of an IAM service for external users so that you don't have to commingle them with your IAM users. Both providers have the concepts of groups that you can assign users to, and you can use those concepts to allocate permissions to groups rather than individual users. AWS does allow you to allocate permissions to specific users, which is generally a really bad idea because then you have to go trying to track down where the policies are set up. OCI enforces permissions at the group level, not the individual user level, so it makes it a little bit more clean there. Now, when we start talking about policies and permissions, or what people can actually do, OCI and AWS take very different approaches. With AWS, policies are attached to the user, or the group, or the role, or inline. Very bad idea. Please don't use inline policies. It makes it very difficult to find what you're doing. Policies, in this case in AWS, can be either allow or deny in nature, with deny being the default design. You also have the fact that a deny rule takes precedence over any number of allow rules. With OCI, however, policies are attached at the compartment level. This makes it very easy to find all the relevant policies that are in place in a given location in your account. You simply look at the compartment that you're trying to assess the permissions for, and any parent compartments going. In OCI, parent policies are allow only with a deny by default design. Now, because policies are attached at the compartment level, you get policy inheritance that allows policies at one level to flow down to your subcompartments, so you don't have to specify all the rules at the compartment level. Both providers allow you to create policy structures that are as complex as you need, and both providers allow you to use tag-based policies to access resources. Now, a key differentiator here is that with AWS, policies are written as JSON fragments, whereas OCI, they're really natural language. AWS, you can use wildcards, whereas OCI has built-in groupings like all compute as an alternative. All right, let's dive into infrastructure and the stuff you're actually going to spin up to make the magic happen. And networking is obviously the first thing you're going to set up. The most basic networking component here is a virtual network. Now, OCI calls it a VCN, while AWS calls it a VPC. Fundamentally, they're similar in nature. You're going to create a virtual network. It's going to be a specific region, and you're going to provide a specific CIDR block for the addresses. One difference there, OCI allows you to modify the CIDR block that you use to create the VCN, whereas AWS does not. In both cases, you're going to have an optional internet gateway that allows instances to have two-way communication to the internet. This includes the ability to use a public IP address and actually connect to that instance. You're also going to have routing tables in both providers that control how your traffic gets routed inside your virtual network. Your network can be broken up into subnets, and those subnets can either be public or private. Now, AWS requires you to bind a subnet to a specific availability zone. So if you have a network that covers 2 availability zones with public and private subnets, you need to have 4 subnets in total. OCI, on the other hand, allows you to either bind a subnet to an availability domain or create a regional subnet that spans any availability domains in the region. It just works. Pricing is also a differentiator here. Now, AWS is going to charge you for traffic that crosses AZ boundaries. They're also going to charge you for traffic that flows through the NAT gateway and traffic outbound to the internet after the first 100 gigabytes. OCI, the only charge is going to be for your data transfer out, and that hits after the first 10 terabytes of data in a month. Another difference here is that if you're using a private connection between your data center and the cloud provider, AWS does provide you with a discounted rate here, while OCI, traffic along that private connection, is free. When it comes to baseline security constructs, you get 2 for each provider. With AWS, you get something called Network Access Control List, or NACLs, that attach to the subnet. These are stateless firewall rules that govern all subnet traffic. You also get security groups that attach to the individual network card. These are stateful firewalls that govern traffic to the NIC. With OCI, you get security lists that are stateless and attached to the subnet. You also get network security groups that attach to the virtual NICs. Network security rules can be either stateless or stateful, your choice. Now, both AWS security groups and OCI network security groups have rules that can reference each other for security groups, which makes crafting rules a lot easier. With AWS, NACLs and security groups are applied separately. First, you go through the NACL as you enter the network, and then you go through the security group. So, for example, if you wanted to have HTTP traffic going to your web server, you would need to allow traffic on port 80 in both your NACL and your security group. In OCI, your security lists and network security groups are combined and applied once, so allowing traffic at either the security list or the security group allows it to get into the instance. So in the case of a web server, you would need one rule applied in either spot for that traffic to get through to your instance. Both providers do have address checking that prevents traffic from being delivered to the wrong instance, but it can be turned off where appropriate. For example, if you're creating a NAT instance or a VPN server. There's a lot of other host networking components that deserve to be mentioned, and they will in follow-up videos, but I'm really focusing on the basic stuff here. So in summary, you've got all the network constructs in both environments that you need to build your applications and have a solid network underpinning them. There's just a few differences in how they're actually applied. Compute. This is really the workhorse of the cloud and where you're actually going to set up things to host your applications. Instances is your virtual machines in the cloud. You spin up a server, you deploy whatever you want, and you use it. Both cloud providers give you a choice of processor. You can do the tried and true Intel processors. You can use AMD for the lower price. You have access to ARM processors as well. And with things being optimized for ARM the way they are these days, you really want to check out if ARM can provide you with benefits for price for performance. Picking your instance type is where things really get different here though. AWS has 15 different families for compute, and each family has obviously multiple different generations. Each one of those families has a different resource profile, so you need to know which is going to be the most suitable for your workload. You don't want to pick a C family compute optimized instance to run a memory intensive application like SQL Server, as an example. Now, once you have the right instance family, you choose the size based on t-shirt sizing, so large, XL, 2XL, etc. Each step doubles on your resources and your costs. So you go up a step, you're going to pay twice as much, you're going to get twice as much memory and twice as many CPU cores. Now, OCI really only needs a few instance families. You have Dense I/O, which provides you with onboard NVMe storage. You have bare metal, which gives you the entire host. You have GPU-backed systems, and then you have the standard compute offering. May not sound like a lot of choice, but that's where OCI's flexibility really kicks in. Oracle's gotten rid of the t-shirt sizing and just lets you choose how much compute and memory you need. You can adjust the sliders and launch your instance. If it turns out you need more memory or more virtual CPU cores, you just shut down the instance, adjust up or down, and then relaunch. With OCI, your cost is based on how much resources you allocate rather than the t-shirt sizing. Pricing for OCI then slides up and down based on that allocation of resources. So if you need one more virtual CPU or one more gig of RAM, you don't have to double your pricing. Now keep in mind, when you start moving from on-prem to the cloud, you're likely to find that instances perform better than your virtual machines because you aren't oversubscribing at the hypervisor level, unless you're choosing burst instance types, which are available on both providers. Both providers provide you access to bare metal instances if necessary, and both providers allow you to have dedicated hosts that may be necessary for compliance or bring your own license situations. So you can look at those on a workload-specific offering. Going beyond instances, you have options that enhance the ability for your instances to perform and meet your goals. Both Oracle and AWS have the idea of burstable instances. With OCI, this is an option that you select when you create the instance, while with AWS, you have the specific T family of instances. In both cases, you get a certain baseline configuration for your CPU utilization, and then you can burst above that for short periods of time. With AWS, the baseline is defined by family and size. With OCI, you can configure what the baseline performance is, either 12.5% or 50%, and your pricing matches that. OCI has the concept of creating capacity reservations in order to reserve capacity you need for specific events. Now, AWS has a similar idea with reserved instances. However, these options work in very different ways. Both are going to ensure that you have capacity available. With AWS, you're making a commitment for either 1 or 3 years. As a result, you get the capacity reserved for you and a discount on price. With OCI, you're not going to get a discount with a price with a reservation. However, you also aren't making a long-term commitment either. You can create and delete capacity reservations as you need. So if I know I'm going to need extra capacity on the weekend, I can create a capacity reservation for the instances I need, and when I'm done with whatever I'm doing, I can discard the reservation. With AWS, you're kind of stuck with it for that period of time, unless you sell it on the marketplace. Now, for workloads that can tolerate being interrupted, Oracle has the idea of creating preemptible instances. This is similar to the idea of AWS's spot instances. Now, spot instances do have a fluctuating price point based on prevailing supply and demand, while Oracle's preemptive instances get a flat 50% discount. In both cases, instances can be taken back, but in both cases, you are going to get a warning before that happens, so you can take necessary actions. Developers have been moving to containers for years now, and it makes sense because there's a host of benefits to running your applications as containers over deploying to virtual machines. When it comes to containers, OCI has pretty much the 4 ways that you actually need to be able to run containers. 1, you can spin up an instance, install a container orchestration of choice, and then completely self-manage. Now that's an option if you really need it to be, but probably not the best use of your time, unless there's a specific reason you can't use one of the other options. 2, you can use container instances. This is a lightweight, easy to use way to run containers if you don't need Kubernetes. 3, you can run OKE, the Oracle Kubernetes Engine, which is probably going to be your go-to for most production container workloads. OKE is a managed service that helps you run Kubernetes without having to handle the underlying infrastructure. And then 4, you've got Oracle Functions, which is a fully managed serverless option. Your function code is just packaged as a container and deployed. Now, I'm not going to talk too much about functions because it's a more advanced topic for another video. AWS has a complete continuum of ways to run containers, from self-managed to fully managed, with multiple stops along the way. If you consider each of the 4 options that Oracle has, there's probably several AWS offerings that match. The hardest part is really trying to figure out which is the right option for you. Now, most customers spend a lot of time evaluating the various options and then settle on 1 or 2 ways that suit their use case. Now, if compute is the workhorse of the cloud, storage is probably the backbone. Storage is obviously critical for all your workloads, no matter where you run them. Both providers have the ability to provide a range of storage options at a broad range of performance and price points. You have different storage options to meet your needs of your workloads. block storage, which I'll dive a bit more into in the next slide, file storage that provides the ability to create file systems that are not directly attached to your instances. Think of this like a NAS that you can access over a network from many instances at a time. And then, of course, there's object storage, which has multiple use cases, such as content management, low-cost backups, and things of that nature. Now, block storage is the storage that you attach to your instances. This comes in two forms. The first is local NVMe storage, which is attached to the specific instance. This is ephemeral storage that you can use like ultra-fast caching. However, you do have to treat the storage as volatile because the data will be lost if the instance moves to a different host. Some databases will use this local storage for an area of memory expansion, for example. Some databases will use this as primary storage, with the data being written first to the local option and then being replicated out to offline storage for long term. There are a lot of different use cases as long as you treat the disk space as being disposable. You have to be able to reboot or rebuild this after a reboot because it may not be there. And then you have the block volume services. With OCI, you have boot volumes and block volumes. These all go to the same service, however, they do work slightly differently. Boot volumes are the more static in nature because they just launch your operating system, whereas block volumes are for your main storage needs. You get a lot of configuration options here. You can have a default balanced performance profile. You can have a low-cost performance option, a high performance option, and an ultra-high performance option. These come with selectable IOPS provisioning that scales with the volume size. In addition, you have features like auto-tuning of performance characteristics of your block volume. So your block volume can scale up to meet the demands and then scale down when it's not necessarily in use. You also have the option to automatically scale the performance characteristics way down when the volume is detached, saving you money. And you can even enable cross-region replication to a paired region of the volume or volume set in near real time as a form of DR. This gives you a crash-consistent copy in the paired region. Now with AWS, you have different classifications of storage with either general purpose or provisioned IOPS. AWS also gives you the option to select hard drives if you want low-cost workloads that don't necessarily benefit from the speed of solid-state drives. So how could we possibly be talking about anything called Oracle without talking about databases, right? Now, don't get me wrong here. Oracle Cloud is a lot more than just a place to run your database. However, you might be surprised to see the wealth of options you have for database workloads running in OCI. There are, in fact, so many different options between AWS and Oracle that I couldn't possibly create a slide to cover them all. Both providers have a lot of different options. To start with, you can spin up an instance and run pretty much any database you want in a self-managed capacity. I'm sure there are some exceptions, and if you're running, say, DB2 on an AIX machine, you aren't going to be able to get rid of that machine just yet. Both providers have managed database offerings, allowing for options like MySQL and Postgres. With Oracle, these fall under the Database Service Collection, and with AWS, these typically fall under the RDS option. Each provider also has its proprietary databases, such as Oracle's Autonomous Database, which allows for not only the management of the database, but also autonomous tuning of the database performance. AWS also has their proprietary databases such as Redshift and Dynamo. Both providers have NoSQL options, caching options, and managed search facilities. Now, one more thing that is unique about OCI is the effort that is being put in to allow the Oracle native autonomous database to run in other providers. So, for example, you get Oracle Database at Azure, allowing you to run Oracle's autonomous databases linked to your Azure account. You could have your front end running in Azure and your back end running autonomously inside of your OCI account. Key takeaway here is OCI is a multitude of database options available for every kind of workload you could need. You have relational, you have non-relational, you have cached, you have Oracle, you have non-Oracle. Feel free to build your application on OCI knowing that you have the freedom to choose a database that fits your needs. To wrap it all up, I've been diving into Oracle Cloud a lot over the last few weeks and finding a lot of features and functionalities out there. Now, clearly being a .NET developer, I'm looking forward to seeing how I can dive in and start deploying my .NET applications into OCI. Stay tuned and check out my upcoming videos. Complete source code for all of my videos can be found on GitHub. You can find me there at github.com/basementprogrammer. Thanks for watching my video. If you found this video helpful, please hit the subscribe button. It helps you to know when I have new content out, and it helps me to know I'm creating useful content for you. You can always find me at basementprogrammer.com, on Twitter, and the Basement Programmer podcast. Details listed here. If you have any comments on this video, or you just want to get in touch, you can always email me. The address is tom@basementprogrammer.com. And I'll see you next time.